Okay, this is the problem of the day, and it says we should solve log x to the base 3 plus 2 log 3 to the base x equals 3. You see that there's a problem here, the bases are not the same. This is base 3, this is base x. And if you want to solve this problem, the first thing you have to do is try to make the bases the same. Okay, so here it means we have to apply the change of base law of logarithms. The change of base law of logarithms. So let's look at how it is being done. So we have log x to the base 3 plus. So here we have to change the base. Now because there's a base, the base over here is 3. It will be appropriate for you to choose base 3 so that at the end of the day they will look alike. For you to be able to simplify it easily. So let's change the base here. So you have 2 here. The change of base law, if you could remember, set log 3 to the base 3 is our new base. Out of log to the new base of the old base. This is what you have, and this is supposed to be. Okay. So what do we do here? Log x is 3. So you can see that here will give us 1. And the 1 times 2 is going to give us 2 on this 3. And this is equal to 3. Okay. So you can see there's a fraction here. So what do we do to remove the fraction? Okay, so we multiply through by the denominator. So you can stay multiply through by log x to the base 3. And this is going to give us so here we also have log. So the 3 2 we multiply it 3 times log 3. Okay. So you can see that this one will take care of this. Then we have log x to the base 3 times log x to the base 3. Look alike. So we take them together now. X to the base 3 all squared, right? Plus these 2, the remaining 2 over there. And this should equal to 3 log x to the base 3. So here what we do is, you can see there's log x to the base 3, log x to the base 3. We can represent log x to the base 3 with any variable of our choice, from A to Z. Or any variable. Okay, so let's say m equals to log. Let m equals log x to the base 3. So wherever we see log x to the base 3, we put our m over there, right? So here we are going to have m squared plus 2 equals 3 multiplying m. As you can see. So let's look at it over here. So we have okay. So this is what we have. This is going to give us m squared plus 2 plus 3m. So we can bring this 3m to come and join the colleagues. We have m squared equals 0, and that's what we have. This is a quadratic equation. This is a quadratic equation, and so this is the quadratic equation that we are driving at. Right? We have m squared minus 3m plus 2 equals 0. And So let's use the factorization. So here we have minus 3 and 2, and we need the two factors. So we are going to have minus 1 and minus 2, right? Well, minus 1 times minus 2 give us this 2. And minus 1 plus minus 2 give us minus 3. Hope you remember that. So let's present inside the coefficient of m. We have 1 squared minus 1m minus 2m plus 0. Here we can put them in the same. M will come out, m minus 1, right? Over here there's a negative 2 here. So look at our negative, you see 2 here, 2 here. So negative 2 out, and minus 1. I hope we are aware of the reason why we are getting negative sign here. It's because of this negative sign which is coming at the back. So that when we are expanding, negative 2 times negative 1 give us the positive 2 back. Okay? That's why the positive sign over here has been changed to negative over here because of this negative sign at the back. Okay, so here we take m minus 1 and minus 2 equals 0. So here we are going to have our m to be equals to, if this one is equal to 0, we are getting m equals 1. Or if this one is equal to 0, we are getting m equals 2. So the values of m are 1 or 2. Now remember that m is not an its own, it is representing something here. We have m to be equal to log x to the base 3. So we can put it back. Okay, so we are going to have m equals to log x to the base 3. So we are going to have log x to the base 3 equals 1. Or next equals 2 over here. So here we are looking for x. So we are looking for x. So here we can change or convert them to indices. And at this point we are going to have, to convert this one to indices, we are going to have the base to be 3, exponent 1 equals x. So 3 exponent 1 is equals to x. And 3 is equals to x for the first part. Then if you look at the second part, we have log x to the base 3 plus 2. Let's convert it to indices. We are going to have the base of 3, exponent of 2, and equals to x. So we are going to have the base of 3 exponent 2 is equals to x. So this is our x1. So here we are going to have 3 exponent 2 plus what? 9 is equals to x, and this becomes our x2. So this is what we have as our solution for the problem given.